Got my Ender 3. Time to unbox. I bought some little storage stuff and some M metric screws. I think these are like assorted M3, M4, M5. Just in case I need to replace any screws or strip any or need to upgrade something. Alright, let's take a look at this power supply. It's supposed to be a mean well, a real mean well. It looks pretty nice. It's much smaller than the other one that I've seen, the original. I don't know why they made this part down here so big. There seems to be plenty of room to put wires in here. It could be a lot thinner. Yeah, maybe they just didn't want it. I would like to make a sleeve to cover this whole thing too. Be pretty nice to hide it. It looks like they put much better connectors on here than some of these fire issues I saw. Those look real nice. I don't know what the difference is, but they look like real connectors. Alright, let's take all this stuff out and see what we got. Ooh, this base is heavy. Let's be careful taking this carriage, this print head out. Check these rollers real quick, make sure they're smooth. This one seems to have a little detent in it. I wonder if the bearings are bad on that. I'll see if it have print problems and I'll replace that, but the rest of them feel good. Off camera can't really see what I'm doing, but I'm just kind of looking it over. I've never had this kind of printer before, so I'm kind of looking at how it's built and how it's designed, how this hot end's designed, and checking how much the angle and bend of these this Bowden tube. Let's check out this Z-rod, this lead screw. It's in this little protective coating. It's not really thick, but it was inside of an extrusion. Make sure it's got some grease in the middle. Yeah, it's got some grease in the middle, so you'll have to run your carriage up and down a couple times to get that to spread out, or use your fingers. But just in the middle
Should be fine. Just run it up and down a couple times before you start using the printer. Let's see what it comes with. It's got lots of tools. I guess they used a lot of different sizes. I could probably fix that a little bit. And it comes with a spatula. This spatula is not that great. It's not even sharpened. It's just, I don't know if they didn't sharpen it properly or it's just flat on the tip, so it's kind of useless. Other people said it was a really nice spatula and they liked it and they used it, but not mine. It's not used. It's completely useless. Alright, I got the glass bed upgrade. I'm going to check this out. Yeah, it's nice. It's got that enameled or, you know, pattern on one side. I'm not really into knolling, but I did find these little bins that are like, I guess, drawer organizers, and they work really good for sorting your stuff into before you start working on something or putting something together. Just laying everything out for no reason seems kind of silly to me. Alright, what else we got? We got a power cord, of course. We got a package here of some hardware. Looks like all the hardware is mostly black oxide with captive washers. Some of them are still silver. These are the belts for the X carriage, and a little pack of filament, and it looks like some Bowden tube couplers. One's already installed, so I guess they give you an extra. I thought these were extra T-nuts, but it turns out it's missing from that piece right there. It actually unscrewed. And these are some extra Bowden. I think one of these goes in the extruder, and one is a spare. And they come with the clips to keep it from popping out. This is the Z index switch. It's pretty nice. I like the way it's on a board, and I probably will have to modify this. There's like a little tab on the bottom. I'm pretty sure it limits your spring tension on your bed. And this is the I think this is the X belt tensioner. Goes in that end of that rail, and these nuts actually belong to that, but I thought they were spares. I wasn't sure if they were spares or if they fell off of here, so I'll put them together over here. Let's check out these extrusions. They look real nice. They're all wrapped and there's no scratches. And yeah, the edges look pretty clean. The Y-axis feels real good. I don't think I'm going to need to adjust these nuts. They seem to be set pretty good. It's real smooth, not too tight, and there's no wobble. If I have any wear on the nuts, I'll loosen them, but I think it's good. This is what I was talking about. These springs are real loose, so to get the bed to level and have the springs tight so that they don't change constantly, you might want to drop your Z index. There's a couple gripes I have with this. Why do they use a rainbow cable? ribbon cable. They could have just used a black one. And this loom right here for the heated bed seems to be all twisted up, and the only way I can think to undo that twist is to undo it from the controller, and then you know, twist it around. But it kind of mashes on this stepper back here when it slides back, which is kind of annoying. I don't know why it's doing that. I could probably just fix the twist and it'll probably stop doing that. For now I just have it held out of the way, but they might have been able to put the stepper motor on the other side. I'm just checking the movement, making sure nothing's catching. It's going to wear over time. These bed wires and stuff like this usually can cause trouble if they're rubbing on anything. Over time they will break. I'm going to have to take this apart to fix this twist that's pushing the heated bed wires into the stepper motor and pinching it. Why did it put the stepper motor on the other side? I don't know. Probably would work better on the other side where it's clear, and then move the limit switch somewhere else. Although the limit switch does not hit the bed, it hits the rollers. So they would have to modify the other side to put something there to hit that limit switch. Let's take a look right here. You can see there's nothing on the bed to hit the limit switch. It just hits the actual roller rolls into the limit switch right here, which might not be the greatest thing. Your limit switch might vary with the wear of your wheels and stuff like that, but it shouldn't make much of a difference. It's not a precision, you know, sensor. I did actually have to move this Y limit switch forward a little bit because it was hitting the limit switch and then slamming into the back of the printer at the same time. So I just moved it a little earlier so it doesn't hit the physical limit. I'm going to take a look at this controller in here. Find out what size these screws are. Looks like there's 3 screws on the back. Take these off. They kind of go through the cover. I don't know what they're going into. Different size screws. It's very dusty in here again. Are you fucking kidding me? Can't take this cover off. There must be another screw on the other side. They kind of could have made this so that you can take the cover off without having to flip it around. It's kind of annoying. This is the stupidest thing I've ever seen. What? So you got to flip it over and take this one screw out. I'm probably just going to leave this screw out so I can get that cover off easier in the future. Of course, the screw is going to fall down somewhere.
Wonderful. Great design. Great design, guys.
I'm just going to give a quick glance at this wiring. I'm not going to disconnect anything, but everything looks good. All the high-powered stuff is all in there pretty good. There's no stray wires hanging out or anything like that. So it looks good. I think I don't know how good the airflow is going to be with all this wiring, you know, over the top of it, but fan probably would be better off suited at the side, blowing across it, not down. I have some upgrades planned for the electronics, maybe even moving it all to the back. If I, you know, when I do that, I'll make a video on how the controller for this works and everything. But everything looks good, and the wiring's all taped up, and there's nothing rubbing or sharp on anything. So I think it's good to start with. I saw some people talking about this cutout right here, and the wires passing through, and they've printed out some guards for this, but this is real nice. The wires are wrapped, and this aluminum is sanded real nice, and it's even smooth. It's even a little beveled to it. It's real nice. I don't think it's going to be a problem at all. Let's look at the instructions. It comes with this little poster kind of board. It's not the best instructions, but it's not bad. Some of the steps could have been a little more detailed, but it's a lot more than you get from some other stuff. And it's got a good overview of the hardware, which is good. So you know you're not missing something. So you want to start off assembling it by these two uppers, and you got to figure out which way they go. You got to put the two holes on the bottom. You just want to tighten these up, not terribly tight. You want them just a little less than finger tight, so they have a little bit of movement, because you're going to want to square them up later. Make sure they're square. These were fairly square from the get-go. I don't know if I got lucky or if they're just doing a better job with quality control of these materials and assembly. You just be careful you don't hold it or pull it by the that extrusion, so you don't bend it or bend the threads and stuff like that. I just flip it over, and I'm going to do the other one. And these go on so that the holes on the bottom are closer together than the holes on the top, on the side. If you don't have a square or something to measure this, just you could always. I've seen people use two clamps, and clamp the extrusion across them, and that kind of helps you square it up. But they're pretty square. I'll adjust them a little bit later, but it's not too bad as long as they're a millimeter, less than a millimeter out at the top. You should be okay. But they're pretty good for screwed together extrusion. I'm pretty impressed with the squareness of it. Alright, I'm missing some video here. I'm not sure what happened, but putting the Z-axis motor on. I know there's a known issue with the alignment of this lead screw, so I'm going to work on getting this shimmed. It took me way longer than it should have to figure out how this one piece goes on and which bar to use. There's like a there's a divot on one side that goes around a bolt head. You can see it right here. That divot, it's drilled out, and it goes around the that bolt that sticks out for the rollers. I could not figure out how that bar was supposed to go on until I saw that. It goes over that bolt hole right here, and these two screws drop through. And that's the way that goes on. And there's no good way to level this, which I found to be a problem. There's no I could not find a good way to, a good surface to square this up. There was really no parallel surface that you could really square against, or even a perpendicular surface that you could square against to at least make sure that this was straight. Kind of eyeballed it, got it as straight to the bracket as I could. The bracket's fairly square. It'll get you within a couple millimeters, just lining it up with the edge of the bracket. And then I just kind of use a small square to just make sure the distances were equal to a couple different features. I've seen someone do something else. They had like a little some kind of wedge that goes in there, and they used it to square up to an outer edge. If anybody has any good ideas how to square up weird shapes like this. Let me know. From what I understand, that bend for the Z-axis anyway is not exactly straight. That's what causes some of the Z alignment problems, requiring shimming of the Z motor. I'm going to put the print head on now, but I think it might be easier to put the belt on first, because then this way you don't have to loosen it up later and slide it over the belt pieces. There's little clips on the end of the belt that make it a little too wide to roll over when it's in the groove, in the channel. So maybe getting it on there first would be easier. You'll see I do it after I put the print head on. I figured it would be in the way if you tried to do it that way, but next time I'd probably try it that way. No idea what I'm struggling with here. I think I was just trying to put the screw on the wrong side or something. Or maybe I was trying to just index it so that it would stay aligned when the others... I don't know. I don't know what I was doing. Drawings aren't the greatest. I tightened both of these brackets on each end of the X carriage, just like a little more than finger tight, just enough to hold it, make sure it was straight, and then when I actually put it on and made sure that the distance to the bed and all that was level, then I tightened it up, real tight. The only problem is they made this really hard to adjust. You can't get to those two screws from that side when it's mounted because the extruder's in the way. If they just figured out a way to put the holes on the other side of the bracket and bolt it through the rail, I can understand why they didn't, because then they would put stress on the rail and it's aluminum, so it would probably widen the holes over time or vibration. But you could still figure some way to do it with a T-slot or something that you could actually access those screws from the other side and adjust the what do they call it, collinear alignment of the X carriage to the bed.
Having never built a 3D printer with like this, or even seen how they operate, I was really confused about how these belts went on. But it was fairly easy. I like the fact that there's no weird clamp block tensioner or spring tensioner. It just kind of clips in, and then you just pull the pulley on the end. I kind of like it a lot. This is the tensioner for the X belt. It's just a little roller that goes on with 2 screws, and then it's I guess they're oblong holes so that you can, you know, pull it and set the screws where you want them. It's a little finicky because you got a T-nut, 2 T-nuts and 2 screws, and you gotta get them coordinated. I just tightened 1 screw fairly tight, not fairly tight, finger tight, just enough to hold it, and then pulled tension to get the tension, and once I had the tension I just tightened it up a little bit and then clamped down really on the other screw. To do that, how do you have to put that on first? How do you can see my dilemma here. How do you get this through when it's already on there? You either loosen the eccentric nut and slip it under. I just stuck it in the channel and then just rolled it over. It's probably not the wisest thing to do. You could scratch your rollers, but it was fairly fun. It was, I mean, I kind of went easy and slow on it. It's kind of a stupid thing to do. I could have really ruined that roller, but another thing that was hard to do is get this loop through here and keep the tension on it and not have it falling off that gear. I think it fell off the gear a couple times, but just make sure it's on that little pulley in there before you clip it in to the print head. This is kind of hard. I wish I watched somebody do this so I knew what the fuck I was doing. These belts just have these brass ferrules on the end of them that just slot into a groove on the the hot end carriage. Right here, it just pops in that little slit, just like that. And they're on there really good. They don't feel like they're going to pop off or loosen up over time like a screw or something weird would. I've seen people use screws. I think the Cetus uses a screw right through the belt.
Just doesn't seem like a very great solution. So here I'm going to loosen these up, pull it out a little bit. I use this Allen wrench to get a little bit of tension. I'm going to tighten this first screw up a little bit. Check tension on the belt. And I'm going to really crank down on this. Get some really good over tension it a little bit, because it's going to loosen up over time, and then I'll tighten that bolt the rest of the way and then really tighten down the second one. And make sure it's not going to slip. And just give it a test run. It should be really taut. Looks good. Alright, so I'm going to slide the ZX carriage over this. You might want to just make sure that you're not going to nick the rollers on the top. You might have to loosen an eccentric nut if it's too tight. I just slipped it on. It was fairly ready to go. Spacing was pretty good. And I just threaded it on. Don't thread from the middle, that's where all the grease is. So just, thread it on there and then slide it all the way to the bottom and check and make sure it's not binding before you start using your printer. Like I said, I'm pretty sure every single person that's assembled this printer has to shim this Z motor. And that's mostly because that top plate that's bent right there that holds the Z bearing is not perfectly a 90-degree angle. I guess they can compensate it. You could probably compensate that with the Z nut somehow by angling it or shimming one side of it. I haven't thought about that. But I mean, you really want the Z axis to be perpendicular to the bed anyway. So you want to really fix it at the bottom. If you have another 3D printer, I highly suggest printing a shim from Thingiverse for this first, or get just some nice like plastic cardstock, some credit cards or PVC cards or something. But try to print the shim first, because you're gonna have to re-level and everything after you assemble it. Once you take it out, if you use something temporary, you're gonna have to take it out and then re-shim it after you print the part. So if you do have another printer or access to another printer, try to get those printed ahead of time. I just shimmed this with some cardboard, and it worked enough to print a couple, pieces I needed. Oh, and don't do any of this alignment or testing or moving with your motors plugged up. Don't plug anything up yet. You'll create a back voltage that could fry your components or your board. There's no protection, and it does generate a voltage in reverse when you spin the motors. So pushing this Z-axis down is not good to do when you have a controller attached. So there's actually a convenient hole right here that I'll just put my Allen key in to keep my carriage from falling down while I'm messing with this coupler, because it will fall down on its own. Just remember to take it back out when you start pushing back down.
So I kept tightening, adjusting this until the X carriage would just start sliding down on its own as I touched it. And it turns out I made it a little too loose, and now my carriage doesn't stay up when it's powered off. So I'm gonna have to tighten the nuts up a little or introduce some kind of tension on this. There's no backlash nut, and it'll probably help with this problem, but I didn't get one because it's the ones that are rectangular and they're not as easy to find as the round ones. So there's a better video that shows exactly what causes this problem. It's not the mounting of the stepper. This bracket right here that holds the extruder and the Z-bearing is not at a perfectly right angle, and it kicks out a little bit, and that's what causes the rod to be a little offset. So I mean, if you wanted to fix this for real, you'd take that all apart and just tap that bracket until it was perfectly 90 degrees. You can kind of see here where it's binding. It's not dropping on its own when I touch the Z-rod. So I'm just trying to find out exactly where the deviation is and where it's where the sweet spot is. And I'll just move it until it starts to slip on its own. I'm starting to get a little pissed off because it needs more shimming. And I'm just shoving cardboard in there, and I wish I had a better way to do it at this point. But at this point, I'm just trying to get it printing real good so I can print some shims. And now that I know that this is such a problem. And smooth as butter. You'll see it just drops on its own, which is kind of a bad thing, but really good because you're not fighting with
any friction when you're raising your Z index.
Yeah, so I'm gonna put the top rail on and see how square everything is. You can see here how every time I touch it, the X carriage just drops. There's nothing holding it. So I'm going to have to tighten something up. Then just start wiring everything up. Everything's got these little beads on them that label the cables, X, Y, Z. Then there's a limit switch, and you know, they pretty much all plug in. You could accidentally plug in the, and I have seen people plug in their, swap their extruder and their X belt stepper, and the bed goes all the way to the, I mean their hot end goes all the way to the end, and just keeps trying to go to the end, and their extruder runs all back and forth and backwards, and that's pretty much means you got them swapped. I think I'm going to leave the power supply and the LCD off for now while I test it. Just keep them out of the way before everything's... once that power supply is secure, you can't really adjust your frame. So, and there's plenty of wire.
I suggest you get a Sharpie and mark which connector this plugs into, because you will forget it every time you unplug it.
Alright, so here we go. Power it up. Let's see what happens.
Just checking the fans, make sure the fans are running before I start turning the heater on. Make sure this x-axis goes back and forth. Make sure it doesn't grind or stop anywhere.
Where's the Z motor not engaged?
Check the y-axis, make sure the bed doesn't bind up on anything, make sure it goes smoothly. Yeah, it looks pretty good. I'm going to check the Z now, make sure the Z goes up. It's pretty fast. Seems to work good. Everything seems to move smoothly, and put this in the middle. Everything seems square. I'm going to tighten this top rail up and start printing. I thought there was something wrong with the extruder. I could not test it. I think it might be locked out when it's not preheated, so that doesn't pull filament out of your cold nozzle, your cold hot end. That's my guess. I haven't really looked further into it, but as soon as I preheated it, it worked fine. So I don't know if something was loose or if that's just a feature of Marlin. It doesn't seem to say anything on the display. Going to check the leveling of the bed, make sure it's well under leveled so that the head doesn't hit into the surface when I start leveling it. I'm just going to do a quick temperature test, make sure the bed's getting up to temperature that it agrees with the screen. And try to measure the hot end too, but it's kind of hard to do with an IR thermometer. You can't really get that. It's really only hot at the the very tip. And you don't want to touch it, that's for sure. So I think it all passes. I think I'm ready to load some filament and do a print test, or at least a level test. Start calibrating the bed and follow up and see how this prints.